Okay, again. So we have partial differentiation equation, and then the difference is df dt and with this dt. So there is a partial once we use this. So why in this equation? So in PDE we have linear and non-linear. So my question actually for this example, my question is why in this solution they are putting the dt like this, not d straight. Why do not d straight? Why we do not use d straight? Any suggestion or any answer from you all?
I'm just taking a guess, doctor. Maybe it's partial derivative.
Yeah. I know partial. I know that's partial. Why we call it as a partial?
Because if it were to be full differentiation, then there would be no variables because there's no t. Maybe
Ya,
something like
sikit
that.
lagi, sikit lagi.
Okay.
Almost nak masuk gol dah. Tapi
uh,
terkena tiang.
aduh, sini lagi Selangor ni doktor. Aduh.
Oh, ya.
Sekejap.
Okay, so dia terkena tiang je sikit, dia terkeluar balik. Almost meet the point of the partial. So, what is the partial actually? Partial derivative. How we can differentiate the partial and full derivative?
Partial derivative, we only differentiate the
Separuh.
associated terms lah.
We differentiate separuh. Yes, correct. We differentiate separuh. Why we call it separuh? Because of we just only differentiate half because of partial, because we have in this equation we have two variable, which is the variable is u and x. Okay. So u variable in u we have t inside. The equation we have t inside. For x also we have t inside. The d full derivative only usually we use for the full derivative. If the partial we combine these two, but this is only dt. So if dt we just u and dt. So we just take a half of this function. So if we only the function is, if we define the function fx equals to anything lah, so 2x square maybe, this is x, 2x square. So we will have df dt dx, okay, df dx equals to 2, okay, x square 2x. So 2, we have 2 kat sini. Okay, so we have 4x. If we have, but it is full because in this function we only have x variable. But if we have f, inside of f we have variable of x, and we have variable of y. So we will have, for example, we have 2xy. So here you need to apply the partial derivative df, okay, df. So you need to apply df d. Okay, first maybe you can take dx, and then you so 2y, and then you need to make another half of the function which is y. So df dy. So you will have 2x. Okay. So it same happen here. The same thing happen here. Because in this equation we have in u we have t and then we have x. Inside of x we have t also. So we just differentiate with respect to t. So that's why uh, you we only apa differentiate with respect to t. So that's why the the function is this. Okay. So if you see this function, so meaning you have a lot of variable inside of u. Also happen to the here we have t x here. So that is how we differentiate. We need to differentiate. The most important here is we need to differentiate between full derivative and the partial derivative. That is one of the thing that you need to know. Right. So next we will go to the a bit not really long, just a medium calculation. But in your final will be quite easy actually. So we will use this definition, this concept to test. So let's consider the general form of the linear PDE. So we have the function u, and then with the two independent variable, which is what is the independent variable inside of u? We have t and u, and in u we have x and t. And then we have again u x, meaning here u sub x is actually this is the function of derivative of u, partial fraction or partial derivative of u with respect to x, and then partial derivative of u with respect to t. So and then once we have this function equals to 0, okay, equals to 0, this equals to 0, and then we said that u is a solution of this equation. Okay, you need to know what is to verify, is it u is a solution for this equation. Okay, for example here we have u x t, and then we have e negative 2t cos x. So meaning this is a solution. This is a solution for this equation. So this is fx lah. Fx. This is fx. Okay, this is fx equals to 0. Okay, you can see. So show, meaning you need to differentiate this based on this. So this is du dt, du dt minus 2 du square, should be square here, du square over d square x. Okay, and then you need to find everything here, du dt. Okay, let's du dt, we have this result. So because we have this function, so the cos x will be a constant. So cos x will be a constant. Cos x will be a constant. So we just differentiate e negative to x, negative to t. So we just differentiate e negative to t. So this is a constant for partial derivative of du dt. So we have negative 2 e negative 2t cos x. So just D is du dt lah after differentiation. Okay, so now so now so now we have du dt. Okay, du dt is defined as this. So du dt is defined of this. Just we need to know that d is a partial. D is a partial. And then we need to have another term which is USX here. USX. What is USX? So USX is 2 d square u over dx square. So you need to differentiate 2 times. Okay, first time you differentiate, you got sin. Okay, you got sin. Because with respect to x, so this will be a constant. So this will be a constant. So so you will get this you just copy. This you just copy and then cos, we differentiate cos, you get negative sign. So that's why this here you appear the cos we will get sign, negative sign. Cos sign differentiate sign we get cos. So differentiate cos we will get, I think there is problem here. Oh no, there is not the function. The function is no negative. The function is no negative. So differentiate cos, you will get negative sign, negative of this function, and then sign. And then you differentiate sign to again this function you differentiate again. So no need to write up d here in front. So you will get cos. So negative is maintained. And then you put into the solution because it is a solution. So u is a solution, so that you put the solution into this, so you can see is it become 0 or not. So you put the formula, the function that you have into the form equation. So what you will get 0. So this satisfied of this definition. So that's why we can conclude that this u x t is a solution for this equation. This also happen same thing here, dx dt. So this is our function. So if we need u double t and then u plus u double x plus 8u, what should you do? You need to find everything that in the equation, so which is utt, meaning double differentiation. You need to double differentiation, and then from here the tips is, the idea here is you need to identify what is your constant. So your constant is because this is t, so the constant is this. So once we identify this as a constant, so meaning you just copy the constant, copy and paste the constant. What will be different is only this. Okay, and then for USS, so the similar thing happened. What is your constant? So this is respect to x. So we will differentiate the x, so the constant will be cos 2t. Cos 2t is we just copy. The difference between here only we just differentiate of cos to x. So how to differentiate cos fx? Okay, cos fx. So katakan y equals to this. So y equals to this. Okay, y equals to this. So y prime, you will have f prime x. sin fx, salin je. Okay, so we will get negative inside, right? Once you get everything, you just put into the equation that they give and just prove is it equals to 0 or not. So once we calculate, there is a same thing here. So 8 of this term plus minus 8 plus 8. So you will get 0. So we can conclude that there is a solution for this. This also happen the same thing for the third one. So the third one is we need to find u as x, u y, and so on. So you can go through. So the most important part is a method of separable variable. So what is a method of separable variable? So you need to have this equation alpha u1 ut and then equals to beta utx. Okay, with the boundary condition UAT equals to GT. UAT equals to GT. And then where alpha, beta, and A is where? A is here. A is inside of U. A constant and GT is a function that they give. So the solution untuk solution for this equation, we can assume that ut is this, and then after that we find ux and ut, and then ux equals to this xt, and then ut equals to xt. And then we assume these two function will give us a constant. And the equation 6.4 I substitute into equation 1 ni, yang ni kita substitute, so what will become like this, and then then we will get this. Once we will get this, that's why we assume this will be negative k. And then from this we separate them because this is t with the t, x with the x. Okay, so okay, this is a separable lah. Yeah, that's involved. So you integrate both sides and then you will have ln t and so on, and then you will get t alpha equals to e negative k t dot ec1. And then t equals to, so what we do here, actually we divide both equation with the 1 over alpha here, and also here divide by 1 over alpha. So that's why you will get this. The same thing happen here. We divide by, to get x, we need to remove the beta here. To remove beta, we need to divide the power of 1 over beta for both sides, so you will get this. So if you can see here, oh saya ada tertinggal satu ke 94. Sama. 95 saya tertinggal. Which is dekat 95 tu. 195 at the page 195. We will have you can see the general solution. Okay, here. So you can see here the t is like this, and then we will have we combine so we know that D is equal, so D is equal, so that's why we can combine here as a U as T. Once we combine, it's become D here because D we define as A times B. Alright. So this is the example. This so we will have a particular find a particular solution of the following boundaries. A volume problem, we have U, the 2UT equals to UX, and then U0T equals to 3E5T. Okay. So, okay, first of all, we apply the formula. Okay, we apply the formula. So we have this x dt dx and t dx dx equals to k. Okay, it is similar with this. Okay, this. So the difference is only the alpha. Alpha is a constant. So alpha is a constant. Alpha is beta also a constant. So if we compare here, the alpha is 2, the beta is 1. So we need to separate them. So separate by using the separable method. So we separate them and then we integrate and then we find the t value. The t is defined as this, and for the x is this. So for the general solution, we can see that. So that's why actually first of all, so kalau you all tengok, if you can refer with the notes that they given to you. So U x t equals to BE dengan plus times AE. So it's also same here. U x t equals to, I just copy E negative K over 2T B E negative K Kx. Okay. And then you simplify A dot B and then E, you combine all together because there is a times, so you will get there is negative K over 2. Okay. And then that's why you will get E this power of negative K. So you will get this, okay. So to obtain, so we need to find the value of D. So how they get D equals to 3? Please answer me. How they get D equals to 3? Tiba kan? Dah semua termasuk goal lah ke? Tertidur. How we get D equals to T? 3.
Tak nampak lagi, doktor.
Bagus. Jujur. Okay, once you tak nampak, what should you do? Once you blur, you just read again the question. Okay, what is our question? Our question is dia tersilap. Okay, this is our question. Okay, so okay, this is our question. So we have actually the solution. They are already given the solution. So what we do actually, we derive in general the solution. So okay, you get this initial value problem. So you will get 3 E5T. Okay, So if you compare here, so you get here, okay, here you get, in general solution you will get, you get u u u u x t. This is general, but here is 0t, so not general, so equal to d e negative k 1 over 2 t plus x. Okay, plus x. So what should, so you just compare, actually compare. Okay, compare sikit lagi, nak go dah, habis dah ni, hampir sepak penjuru ni, sepakan penjuru. So you will get, okay, so D, obviously we compare, we will get D equals to 3. So what is K? So that's why I said that, okay, K will be negative K 1 over 2 equals to, okay, why we ignore the X here? Why we ignore the X? We just compare E. Okay, we have E 5t equals to E negative K 1 over 2 T plus minus Kx. So why we just ignore the X? Because X equals to 0. So because they have no term of X at this side, so 5t. Okay, so 5t equals to negative K 1 over 2 T. So we can put T. So K will be negative 2 times 5. So we will get, so ni habis lah. Okay, just because we want to compare what is the value of K. So we will get negative 10. So that's why you will get negative 10. So once you get negative 10, so we can conclude that this boundary value problem u equals to xt equals to 3 e 5t plus 10x. Kenapa jadi 10x? Because you put again the, actually we have another calculation here. So we have another calculation. Okay, once you get E and then you put again in the general solution here. So you put this, all this value. Okay, all this value you put inside here. So U x t equal to D. D is 3. E K is negative 10. 1 over 2t plus x. So you will get 3 a negative 1 over 2t, sorry, negative 5. Delete. Saya nak delete. Eraser lah. So you will get negative 5t plus, so you times here, so no, plus is minus, so it will be minus 10x. Okay, so that is your final. Okay. That's why we get 5t plus 10x here. Okay. Okay, that's all for tonight. So heat question, you can see in your textbook they apply separable also, but the second order, for the second order, meaning you need to differentiate 2 times, and then you will have wave equation. So I just go through. So the maybe you can use later on, but actually there is an application of the previous method. Just the function is quite they add a few function, for example, second derivative, Fourier series. So for the series solution of heat equation, they will involve you Laplace coefficient, and then after that you will learn about a wave equation. So wave equation also apply separable but in the second order. If you can see, the difference is a second order. So you need to differentiate 2 times, and then after that the series of solution of the wave equation you will got. You need to find in terms of the Fourier coefficient of Fourier series. So there is application. So after that, no more things and then exercise. So that's all for today. So you all nak attendance secara bertulis tutorial. So maybe you can, sebab seorang je, siapa tadi? Akil je yang apa ni kan. So dia selamat daripada buat tutorial. Soalan yang saya akan pilih adalah, kita tak ada exercise, sabar je lah. Okay, maybe you can find, try E, 2E, exercise 6E. As your attendance, kecuali yang respon saya kat tadi. Zawawi pun ada respon tadi kan. 2 orang je respon malam ni. Aidil Afiq dengan Zawawi, kata silap saya.
Thank you, Doktor.
Thank you, Doktor.
So you all dua tak perlu ni lah. So yang lain semua senyap je, saya tak sure you all tengah buat apa. But it's a normal once we do the online class. So to make sure you get something today, so please do 2E. I think no need to E. 2D, okay? 2D. Bagi yang lain, menyesal kan? Tak apalah, nanti lain kali respon sikit. Baru kadang-kadang tu ada advantage juga respon. Okay, selamat bercuti. That's all.
Thank you, Doktor.
Terima kasih, Puan.
Rezeki orang respon mana ni? Sebab saya rasa keseorangan. Kesenyap. Biasa siapa respon? Sofia. I want Sofia.
Ada.
Ini Sofia biasa respon.
Ada, Doktor. Selamat bercuti, Doktor. Selamat Hari Raya.
Alright. Okay. Tak apalah, buatlah. Siapa yang respon tadi kalau boleh buatlah.
Okay, Doktor.
This is much better lah supaya you understand, get something lah. Alright, thank you. That's all.
Thank you, Doktor.
Alright. How to stop?
Selamat Raya, Doktor.